Thank you, Jackie. I work in the structures design section, and today I'm going to be going over some of the major changes to the 2012 design standards, which also includes some of the updates that we did in July 2011 as part of the interims. First, we're going to go over some website navigation, specifically looking at some of the structures support documents that are available there, the instructions, data tables, and some development design standards. Then we'll go into the more significant revisions to the structure standards, and hopefully at the end we'll have some time to look at future structures design standards. You may have seen this yesterday if you were tuned in to John Mothner's presentation and Rebecca Hatton's. This is the new homepage for the structures design standards, and the new yearly format, which is designated as the fiscal year 2012-2013 design standards, has a slightly different format. If you were to click on the DSE link here, DSEB link here, you will go to a listing, traditionally how each index was listed by row, but we also now have additional documents on the right hand side next to each index number which identify the instructions, data tables, and we also have links to the DGNs so you can download the CAD files if you need to do project specific details. There are some terms of use associated with those DGNs depending on the size of the change that you're making. You may be just adding a small detail to the plans which supplements the design standards, or which would just require a reference to the design standards and then the special project detail. It may also involve a very significant change where you take complete ownership of the design standards and put the complete details in the plans and sign and seal those. But I encourage you to look at the link here on the top of that column, and that will give you all the information that you need. Looking now more specifically at the instructions, you have the ability to download the complete instructions book, which has all the structure standards information listed. In time, hopefully there will be other indexes relating to the roadway standards included in this format. At this time, we only have those related to the structure standards. This has been around for a few years, and if you were to use the bookmark tab on the left hand side, you can navigate to an individual index, and then when you look at each index, there is some of the design assumptions, limitations, requirements for the plans, and then the data tables that are associated with many of the design standards are shown in there for your reference. Occasionally there are revisions to these, and we designate those by a revision bar on the left hand side there. There's also a complete listing at the end of the instructions manual, so you can identify or read through those if need be. Back on the main standards web page, instead of downloading the entire instructions booklet, adjacent to each of the index numbers there is a individual instruction. There are also links to the individual data table, cell that would be required to be completed in the plans, and the individual DGN that the design standard was based on without the instructions, without the design standards border. If you were to download the entire DGN file, it's a very large file, but this enables you to take individual sheets if necessary to borrow the details to adapt to your needs. The data tables themselves for production purposes are actually included in the FDOT CAD load, and they are accessed through the structures bar menu. if you go under the Cells tab and navigate down, you will find a complete listing of each of the data tables under each index number. For example, we have the box culvert data table that we looked at earlier there. We still have some of this information available on the structures web page, as we traditionally have for the last few years. So if you need to access that information, it's also available. We have some of the older cell libraries there also. If you're doing a project that is before the implementation date of the new standards, then you may need to use one of the older cell libraries. There's also a lot of other good information there. The load rating summary tables, which aren't actually part of the standards, so they're not included in the instructions booklet, so you can view those in PDF format from our web page. And then there are other support documents there. The structures cell library, which has all the CAD details, and then TrueType fonts is really only for other states that are trying to view our documents, our CAD documents accurately. And then we also have links to previous presentation update trainings available at the bottom there. I mentioned in the beginning about development design standards. This is a relatively new process where we're utilizing this concept for standards that we want to closely monitor their implementation, or they have limitations on their use. If you click on the DDS link on the home page, you'll see a listing of each of the development design standards that are currently available. At the moment, there's really only one new one, which is this GRS geosynthetic reinforced soil bridge abutment standard that we'll talk about at the end of the presentation. We also have a few other ones there that were really design standards that got moved out of the booklet and for one reason or other, but they're still available if there's a need to use those on a project basis. For future revisions, you'll be able to see those revisions directly on the website adjacent to each index number, and then there is also a link on the home page to see a roll-up of all the revisions that do occur. With the new yearly cycle, the number of revisions will hopefully be a lot smaller than they were when we had the 6 monthly interims. Currently, there are no structures revisions to the 2012 booklet, but that may change later in the year. Yesterday, John went over the R1301 revision, and this is for guardrail and guardrail transitions, but this would be the format that you would see. Adjacent to each index number, you would see that there was a revision appropriate for that index number on the right hand side. And then if you were to click on that link, you would actually go to a breakout of everything that's included in that revision for that time. We would try to group a number of standards into one revision to consolidate the number of updates that may be necessary. You'll be notified by Railway Design Bulletin if there is a revision to the design standards. So make sure your contact mailer information is up to date. Okay, let's move on to some of the revisions to the design standards that happened in July last year and January for the ebook. You can get a complete listing from the design standards homepage on the revisions sheet, which this link here would take you to. That's going to be a roll-up of all the revisions from January 2010 through to July 2011, and actually through to January 2012. So for this presentation, we're only going to discuss those since the last update training which happened in July and this January. The revisions may be merely editorial or reorganization, minor in nature or pretty significant. We have one code change here that made for some major revisions to the precast sound walls, and then generally we're always trying to enhance our system, so those are all the reasons for updates. The first one, this is really a drainage index 200, but we had a hand in the structural part of it, and Jennifer didn't talk about it before the break today, so we essentially added a structure size based on industry request, and we also added options for a thinner wall for the precast drainage structure bottoms for the larger boxes to reduce the weight of transportation from the precast plant to the field. So that was really for industry. Moving on to concrete box culverts, we've added a detail in there for the for an underdrain and a wing wall weep hole. There was a bit of a conflict with the construction specifications requiring weep holes in the barrels of the box culverts, and no details actually being provided. This should clarify the requirements, and the construction specification 400-6 was updated to reflect these changes. On the same index, we've also added another option for extending existing box culverts. Traditionally, we cut back the existing culvert face 2 feet and splice onto the reinforcing that's projected out. We've also added this, what we're calling a type 2 connection, which is an adhesive dowel connection where you can dowel directly into the face of the existing box culvert depending on if certain conditions are met, and those are discussed in the instructions for the design standards under that index number. So I encourage you to read through that and look at these changes. This should eliminate the need in some cases for temporary sheet piling adjacent to the face of the box culvert, where you have a roadway shoulder close to the edge of the culvert. So hopefully this will reduce the costs of some of these extensions. As part of that change, the designer will need to complete Note 8 in the box culvert data table, and it can either be one type of connection or both. Just a point to note that the quantities won't be reduced for the type 2 connection, even though we're not cutting back the existing culvert 2 feet. There would still be an additional payment of 2 feet in the length to cover the cost of the connection. Moving on to Index 291, which is the precast culvert details. Similar changes were made to reflect the addition of the type 2 connection to the cast-in-place culverts. Index 292, which are the pre-design culverts, we've added another detail showing an option for splicing the reinforcing cage, consistent with what is currently done in the precast industry. And this is also the same as what's shown in the ASTMs for the RFD box culverts. I think it's ASTM C1577, which we based our designs off. So that should clarify some of the shop drawing reviews where you have a different configuration shown in the shop drawings than it's actually shown in the design standard option 1 details. Moving on to the traffic railings, we have added a transition detail to the vertical face combination pedestrian traffic railing. We added this same detail last year to the F-shape traffic railing with the with a bullet railing on top. This is probably just an oversight that we didn't do it to the vertical shape. The purpose is to eliminate the potential snag potential on the approach end of the traffic railing where the aluminum bullet rail would terminate. So we have this tapered down section which is attached to the top of the railing. The details for the aluminum pedestrian bullet railing, we've made a significant number of changes to sheet 3. We've added another option for fabricators to construct the tapered end transition, and I'll have a slide on that next. We've also simplified the shop drawing note where you have straight bridges. You don't need to show every single post on the shop drawings, and we've added some guidance for uniformly spacing the posts along the bridge length, and then eliminated a slight conflict on the location of the splices. We have a variable range of location that the splice can be located adjacent to the post, and that's consistent on all the traffic rail, on all the railings that have bullet railing attached to the top. This is, you can't really tell here, but this is the detail for the new double-mitered transition option. Essentially, the fabricators had a lot of problems trying to construct this as a single mitered joint for constructing the flare back as well as the taper down vertically, and so we're allowing them to construct that in 2 phases with a horizontal taper and then a vertical taper. So designers shouldn't really get too worried about that, but fabricators seem to like it. Moving on to the precast sound barriers, this was a rather significant change to the design with the release of the 6th edition of the AASHTO LRFD bridge specifications. Added a section 15 bringing in sound barrier design, which used to be under a guide specification using allowable stress and load factor design. So we reanalyzed our existing sound walls using this criteria and the FDOT wind loads, since the wind loads included in Chapter 15 aren't as current as those that we currently use in Florida. So it's sort of a hybrid of the LRFD load factors with the FDOT wind loads. As part of that wind loading, we're now consistent with providing 3 wind categories: 110, 130, 150 mile an hour. We're still providing 2 options for the soil density, and the bottom line with this change is that the new 130 mile an hour LRFD wind load is approximately equivalent to the old 110 what's that, 3-second gust. No, sorry, the 110 was fastest mile, and the 130 mile an hour wind is now using the 3-second gust criteria. And so essentially those wind pressures are about the same. There are some subtle differences with load factors and resistance factors which affect the design, but not too many. No increase in depth of the foundation, which is good. We've also added a low clearance foundation option. This is where we have overhead utilities and we need to reduce the height of the post during the installation. Our current design for the standard post is the full post height and then the full auger cast pile depth with the reinforcing penetrating down in the foundation, so you can get significantly high lengths of post there, like 50 feet plus. With the low clearance option, the foundation is actually 2 separate cages. You have a separate rebar cage in in the auger cast foundation, and then a 6-foot splice length, or really a 4'6" splice length that gets dropped into the foundation. So this should help. It may not resolve all the overhead clearance issues, but it'll certainly go a long way to help. There was a new sheet added, as mentioned earlier, for the additional wind zone categories. So use those as necessary. The data table that goes with that index also had to be updated to accommodate the new wind speeds. So now the designer is required to complete the wind speed in the table. There's also a back of face of the post texture option. It used to be just smooth, but now we're adding the option for different textures. And there's also a column now in the limits of anti-graffiti coating. And the minimum height should be listed in that table. There's some guidance in the structures manual, in the structures design guidelines. I think in chapter 4 about the recommended heights. And I'm sorry, that's the structures detailing manual. And I think that's 8 feet generally, but districts may have some more stricter requirements. So consult with your district structures engineer on that. Moving on to the traffic railing on sound barrier, sound barrier and traffic railing. The junction slab, we updated this last year to reduce the junction slab width, and now with the new 150 mile/an-hour wind speed, we've had to increase that width to accommodate the stability from those increased wind loads in the higher wind category zone. So there's now a type 2 option, or a type 1 option was the original 5-foot design, and type 2 was a 6-foot. And you would just designate in the plans which type of junction slab was required on your project if you had this type of structure. Last year we presented the revisions to the organization of the retaining walls, where we consolidated all the retaining walls into the 6000 series. This year we've had some minor improvements to that based on those changes. The industry requested that we increase the coping height. So on the next few indexes I'll present some of the changes that are required because of that increased coping height. Okay, on index 6020, we've added a detail here that shows how to transition from the standard 2'3" coping height to the traditional 2-foot coping that typically you would see on approach slabs. We also deleted this detail about the build-up because those details are added on each individual index that has a cast-in-place coping. On the traffic railing junction slab index, we've also changed the note to allow slip forming of the traffic railing portion. The coping and junction slabs still have to be cast in place with stationary forms. We've also corrected note 3 there, clarifying that only class 2 concrete can be used in a slightly aggressive environment. It said moderately aggressive last year. And we've added a minimum 12-foot length for the cast-in-place end sections on these precast traffic railings. You generally don't have an exact multiple of 12-foot length, so you need a cast-in-place section at the end, and we don't want a short length that could potentially be unstable with an impact from a vehicle. So there's a minimum 12-foot length there, consistent with the designs for the precast railings. The sheet 2, which details the precast traffic railing and coping, was updated. This 2'3" coping height that I mentioned earlier is really to accommodate MSE wall panels on a slope where you have the potential for stepping different panel heights, and at the industry request, the number of panels that will be needed and the number of custom panels that will be needed to be fabricated was deemed excessive. So we increased this free height here, which is back to what we were previously in the 2010 design standards, essentially. Same changes have essentially been made for the cast-in-place traffic railing version, and we've also updated the bond breaker material between the top of the wall and the underside of the slab, and tweaked some of the details for the cast-in-place keyway on the cast-in-place coping to accommodate the stepping of the panels. Similar changes were made to the raised sidewalk junction slab, and the pedestrian parapet cast-in-place sidewalk did not need to be revised to a 2'3" coping height, so it's remaining 2 foot at this time. So that's something to be aware of. I'm skipping through some of these because I don't want to run out of time at the end here. But the Astro and Bulb T beam series has been deleted from the latest design standards. We are now exclusively using the Florida I-beams, so the associated bearing pad and bearing plate indexes were removed also. The inverted T-beams have been deleted from the standards, but they're still available as a developmental design standard. These were not used very much at all, and so they're still there if you need them on for a specific project, but they don't really need to be evaluated during the BDR phase as an option. The pre-stressed slab units, which were new to the 2010 design standards, I think they were a January interim. Those have been moved to the developmental design standards also. We want to closely monitor the implement or the use of these elements. There are some restrictions on where you can use them also, so the decision was made to make these developmental design standards. So you just contact the monitor if you have a project that needs these, and we'll get you some drawings if they're appropriate. The bearing plates have been updated slightly. We had 2 indexes that had the same name, and we're now designating those Type 1 and Type 2. The index 511 was the most significant change, where we've changed the shape of the bearing plate to essentially from a trapezoid to a parallelogram. You'll see on the next slide. These are intended for beams with end diaphragms and for skewed end beams. The index 2512, which was the standard bearing plate for use with the Florida I-beam, where we have squared the ends of the beams and we're no longer constructing diaphragms. That is the preferred bearing plate for use with those types of beams. This drawing here just shows the change from the old trapezoidal shape to the parallelogram shape. You ended up on a heavy skew with a lot of excessive steel that was really unnecessary. So that change resulted in obviously changes to the data table, so make sure you're using the appropriate data table if you have a need for the 2511 bearing plates. For the pile data, for the pile standards, the 2600 series, the pile data table has been updated to add in some columns for uplift if you have uplift loads on your bridge. You can use the standard table. We've also deleted the embedded data collector note. It's no longer mandatory. There's a bulletin that came out last year on that. The contractor still has the option to use the EDC is as part of the dynamic load testing requirement, but we no longer have to mandate that on every project. Refer to the bulletin for more information on that, or it's actually the information is now being rolled into the structures design guidelines under 3510.F. On the same lines, the drill shaft data table, we don't actually have a standard associated with that, but we have a need to include that in all projects with drill shafts, so we've added it to the data table cell library, so it is available for designers. It matches that one shown in the structures detail manual in chapter 11. You can access that from the structures bar menu. Since it didn't have an index number associated with it, we've named it 0000 at the top of the list there, so it should be easy to find. Where have I got? 12 minutes left. Index 2900, the Approach Slab series. Very minor changes here. We deleted a note that was redundant with the construction specifications. We've also added in the same detail we talked about earlier with the transition from a standard 2-foot coping, the Approach Slabs, to the 2'3" for the precast junction slab details. Okay, moving on to the fender systems, where was a major reorganization last year in July, where we simplified this to 2 indexes. We eliminated the heavy, medium, and light duty designations, and so now we just have 21900, which is the polymeric piling fender system, essentially plastic piling, and then we also have the pre-stressed concrete pile fender system, which is under 2930, which was essentially the same details as the light duty. The pre-stressed concrete pile fender requires project-specific approval at the district level, and you can see the instructions for design standards for more information on this. For the polymetric piling standard, the index shows standard geometry details with a few options in there, and then the vendors are required under the specification to submit piling configurations for approval on the QPL. So those piling configurations are approved for certain levels of energy capacity, and as part of the fender system design, the engineer for the EOR for the project will be required to establish a required minimum energy in the plans and list that in the plans, so that the contractor can select a fender system that meets those minimum capacities. It's rather involved, so I won't get into it here, but if you refer to the structures design guidelines, there's a lot of good information there on the design criteria and assumptions, and then the instructions for design standards to advise you what to include in the plans themselves. Okay, the development design standard GRS-IBS, which actually stands for Geosynthetic Reinforced Soil Integrated Bridge System. There was a bulletin that came out about a couple of weeks ago, that details the implementation of this development design standards, and it updates the policy and design requirements that were originally established about a year ago. Last year, I think in April, there was a bulletin that came out on that. The standard is available. Just need to contact Larry Jones, the monitor, for that to discuss the application of that on a particular project. There is a developmental specification that goes along with these systems, and there's a link provided on the website to view that. On the next slide here, we just have a screenshot of the general system. So this is currently only set up for flat slab bridges. In the future, hopefully we'll have a system for beam bridges, but the details have to do with supporting the bearing loads at the end of the bridge here. So please review those bulletins to determine whether you're appropriate for your project or not. Okay, as far as the future standards that we're looking at, I think I mentioned this last year that as part of the FHWA's Everyday Counts initiative, we're looking at precast pile caps and precast deck panels. We have an in-house project that's currently in design that's going to be utilizing both of these systems, and hopefully, depending on the success of that, we'll be able to provide developmental design standards for other projects around the state. The construction date for this in-house project isn't until early next year, so we may not have any good information until later next year. So we'll see how that works out as far as implementing the new standards.